So hello everyone, welcome to my channel. And our today's question is sliding window maximum. So what problem statement is, we have given an array or a list and we have given number of elements with a k value. K is a value, that is any value, and we have to return the maximum element within that k size window. So suppose we have a list in which 10 elements are present and k is 3. So our window will be moved from 0 to n minus 1 elements, and up to them our window size will be like 3 element size, and whichever will be the greater element in all the 3 elements, that will be add on in our vector. And after that our window moves to next element, uh, and our next maximum element will be encountered, and that will be also put in our vector. In the end we have to return all the maximum element that can be possible in our k size window. So this is the problem statement. And for the brute force, what I have analyzed, I will be using a array and a list. So in this maximum up to which we will be reaching, like our loop will be traversed from 0 to n minus k element, because the last window will be up to mean there if k is 3, so n minus k will be the last element up to which we will be encountered, and our array traversal will be completed. So our first loop will be run from 0 to n minus k, and in this our maximum element will be initialized as our array of I. That will be our first element, that will be known as maximum element. And after this our second loop will be run from j equals to I to I plus k minus 1. That is nothing but the element that we encountered in our loop. So why I plus k minus 1? Let's take an example and understand that. So suppose we have an example of 1 3 minus 1 minus 3 5 3 2 1 6. So these are the array element, and our first window will be moved from 1 3 minus 1. So 3 will be the largest element, and with this our window will move to next element. Means we will be just moving our, we will be removing our first element and adding next for another element. That's how our slide window will be slide. And our now 3 elements are 3 minus 1 minus 3, and in this 3 will be the maximum element. After this 3 will be removed, and a new element, that is 5, will be add on. So we are moving from one index in every step, and removing our previous first index of our window. So that's how we will be moving. So if our n is 9 uh, so we have total 9 elements in this example, and 9 minus 3 is 6. So overall y I plus k minus 1 in our second loop. So 0 plus 3 minus 1, why it is written, means 0 is our first index plus k, that is our 3, and minus 1 is our in our formula. So if we done this, so we will get the 2 as our new element. So our last element, or mean the last window, will be encountered previously before the our third element. Means the last window will be our last window in which our first element of our window will be the last third element. So that's why we have used this formula I plus k minus 1 in our second loop. So again revising, our first loop will be run from 0 to n minus k, and maximum will be initialized. And after that second loop will be run from I j equals to I to uh, I plus k minus 1, and in this we will be comparing our maxi is equals to max of maxi comma array of j, and whichever will be the greater will be put in our stack. So in the end we will add all the elements in our list which will be the greater, and in the at end we will return that list or array. So that's how we will able to solve this problem by our brute force solution. So for the brute force, our complexity will be 0 big O of n minus k into big O of k, n minus k for our first loop and big O of k for our second loop. So that's how our time complexity reaches, and for the space complexity we are using extra space of big O of n minus k will be the maximum number of element that we can push in our element. Means there will be a chance that only 2 or 3 elements that are not included. So that's why maximum length on which our window will be slide is n minus k. That's why our space complexity is big O of n minus k. So what will be the better solution, because it is taking big O of n squares amount complexity and running in 2 iterative loops, so it's not the best solution. So for the better solution we will take k elements and keep our window elements. Means we need a data structure that can take elements and push the element while taking the element from a side and pushing the element or removing the element from another side. So we cannot take the stack exactly, so we will be taking a new data structure, that is dq. So dq gives us a power to push the element from same side and pop the element from same side as well as from different side. So dq is just like a open stack where we can put, it's just like a pipeline where we can put the elements from any of the side and pop them out from any of the side as we require. And in this question we will be putting the elements in a monotonic type stack, and we are using the decreasing order. Why decreasing order we will discuss later. So our elements example, we will be taking the same example: 1 3 minus 1 minus 3 5 3 7 1 6. So these are our element with index 0 to n minus 1, that is 0 to 8 elements, with k size k will be 3. So in our dq we will be putting our index value rather than the values that of array, and we will take the array value to analyze it, but we are taking it hypothetically like we have done in previous questions. So we are actually putting the index element in our dq. So let's take the example and try to run what we want. So we will be pushing the elements from a side and popping the element from another side in this question. And from the front side we will be popping element, while from the back side we will be pushing the elements. And we will be popping elements from front side also if required. So where they will be required we will discuss it. So first element is 1 with index 0. So we will just put the 0 in our dq. And next element is our 3 and its index is 1. Because 3 is greater and we are storing the element in decreasing order, so we have to pop out 1. And in our window, in our first window, if we notice that there 3 will be the maximum element. So if we have 3, so it's clear that 1 will never be the greater element in that list. And because since 1 comes first, so it will pop out first and our window will move again in front ways. So that's why we will be popping out 1 and pushing 3, 3's index. So 1 will be put in our dq and move forward. Now compares, now second element is minus 3 minus 1. So minus 1 is smaller than our 3, so we will push back its index 2 in our dq. Then minus 3 is smaller than minus 1, that's why its index will be put in our dq 3. And now comes 5. So 5 is greater, and 5 is greater than 3 minus 3, thus its index will be popped out from our dq firstly, so it will be popped from our backside. And now comparing to minus 1 is also smaller than 5, so it will be popped out, its index also will be popped out. And 3 is also smaller, so its index will also popped out. So in the end we will be have an empty dq in this case, and we will be pushing the index of 5, that is 4, in our dq and popping out all the previous elements. And while popping out we can clearly see for the first instance where we have 1 3 and minus 1. So we have encountered, when we encountered minus 1 in our previous case, so we have k value will be decreased and it will goes to 0. So we now we know that at that time whichever will be the element on the top or in the front of our dq, that will be the maximum element. So that's why we have the index value 1 and our front value. initially. So 3 will be the maximum element. And now for the case of now for the case of minus 3 element, when we were on minus 3, 3 will also again encountered as the maximum element. So again 3 will be our value. And after that, now as we are on 5, and there are no such element that are greater in our DQ. That's why we have popped out all the elements and returned the 5 as our maximum element and push that index in our DQ. And now moving forward, we have 3, and 3 is on index 5. So we will be pushing 5 in our index, and because its element is smaller and it is in decreasing order, we will just continue. And after this, our next element is 7. So before 7, our 3 elements are already completed. So in this 3 elements, 5 is the maximum element, and after this, when we put the 7's index, that is 6. So our 7 will be the maximum element, so we will be returning our I index array element. So that's how the flow will be all over covered, and up to our n minus k, n minus k, I minus k distance, we will be running the loop, and our window will cover eventually all the elements, and that's how we will be able to return all the maximum arrays and element. Coming upon its pseudocode, we will be taking a function of which have an array and a k value, and in this we will taking a list and a dq. In this, our first loop will be run from 0 to n minus 1, where we will be check if our dq is empty or not. If it is not empty and there is a case like our dq front element is less than or equals to I minus k. What is this? Let's discuss. So dq dot front element means the element which is in the front of our dq is less than or equal to I minus k. What is I minus k? I minus k is nothing but the window size first element. So I minus k, if it is the case, means our front element is already greater. So we have, no, it is smaller. Our front element is smaller, and our next element is greater. That is the case where we have 1 and 3. So 3 is greater and 1 is smaller, and it is already present in our DQ. So what we have to do? Yeah, we have to pop them out. So firstly, sorry. So we will just pop out 1, and after that we will check another condition, and that will be in a while condition, where we will be checking is our DQ is empty or not. If it is not empty, then we will be checking is our arrays DQ dot back, means array element which was present in our list or in our given array, that is arrays DQ dot back, means DQ dot backs index array. Okay, the element that is present at the index DQ dot back index is less than equals to array of I, means our current element is way big greater than our array element that was in our DQ size. That is again the same case, and in this case also we will be popping the element but from the back side, means we are popping them from back side. Previously we was popping from front side, now we are popping from back side. And after, in the end, we will be pushing DQ element DQ dot push I, means we will be pushing the index of that element if it is greater and not present in our DQ. So we will be pushing that element and checking if I is greater than k minus 1. If it is the case, means our index is greater than the uh, index is greater than our k minus 1 window size. So in this we will be adding our element in our list, and at the end we will be returning this list. So that's how we will be able to solve this question. For the time complexity, we are taking big O of 2n, big O of n for our first loop, while big O of n for our while condition, where we have checked is our element is greater or not. If it is greater, so just pop our front element, or if it is not, so pop from back side. So that's how we will be able to solve this question, and tomorrow we will discuss the celebrity problem. So we have targeted to complete the stack in the by the end of the November, but we are not able to complete that. That's so regretting. But we are about to end our stack journey. We are just 1 or 2 day ahead, and after this we will be practice 10 days continuous strike on stack and queue problems, and we will be solving the lead code problems. And after solving them, we will be moving to our next topic that I will be discussing further videos. Until that, stay tuned, stay happy.